Hello. So, hi students. I hope all of you are doing fine. So, in next couple of lectures, we will cover the last part of our syllabus, which is pending uh, in econometrics course. So, basically, we are yet to cover the models with a qualitative dependent variable. In first four modules of our syllabus, we dealt with various types of models like single equation model, in that simple regression, multiple regression, and then simultaneous equation system. In all those models, both our left hand side variables and the right hand side variables were quantitative variables. Then in the last module, the first part dealt with those econometrics model where one or some of the right hand side variables are qualitative in nature. So for that we had used dummy variable for analyzing the impact of qualitative variables on the dependent variable. Now in this new set of models which we are going to discuss today and in next couple of lectures, will be dealing with models where your left hand side variable, that is your dependent variable, is qualitative in nature, and your right hand side variables can be quantitative or otherwise. So let us take up some example. Say if you are trying to analyze how a student is deciding whether to go for higher education or not. Think of all your batchmates, classmates for your BA economics, in your BA economics class. So now, out of all your friends who studied with you in BA economics, some of you decided to go for higher studies, joined for higher studies, say for example MA in economics, and some of your friends didn't join. Now, when a student of BA economics, after completing BA economics course, decides whether to go for higher education, that is whether to join for MA economics or not, there are several factors which will be influencing his or her behavior. Okay. So as a econometrician, if you want to analyze that behavior, you can use one of such models which are going to discuss. If you assume that there are principally two factors which determines whether a student of BA economics is going for MA economics or not. Maybe those two factors can be the CGPA score at BA economics level, that is the percentage of marks at the BA economics level, and maybe the parents' income. We can think of these two important variables, so which will determine whether a student is opting to go for MA economics or not. Say generally, if percentage of marks is high at BA economics, then the student will be motivated to go for higher education, number one, and that also reflects that the student has good understanding of economics, BA economics, so he or she will be more comfortable to join for MA economics. Now, going for higher education along with good score, in case somebody is not able to get a scholarship, then the second factor is financing the education for MA economics. So, in that case, if somebody's parents have a good income level, then that also facilitates for joining for MA economics, that is going for higher education. If parents are poor, household income of the student is low, then perhaps he or she may be compelled to go for a job rather than going for higher education. So of course there could be many other factors in addition to these two, but for keeping our model simple, perhaps we can think of two important factors like the CGPA score at BA economics and parents income. These two important factors influencing whether a student is opting for higher education or not. So here the decision is whether to go for higher education or not. That is, what is the probability that the student is getting admitted for economics or not. Okay, so that way the left hand side variable is no more a numerical variable. Okay, here there are two choices: either student is going for higher education or the student is not going for higher education. Okay, so like earlier, for qualitative explanatory variable we had used dummy variable. In this model also we can use dummy variable, to capture the student decision for going for higher education or not. For example, if the student is going for higher education, perhaps we can basically collect sample among your batchmates. Say in PG you had, in BA economics you had, you were around, say 60 students in the class. Then you can conduct a survey among your classmates, how many of them went for higher education, how many of them didn't. Say if your sample number, observation number 1, you get the information whether he or she has gone for higher education or not. If he or she has gone for higher education, got admission somewhere for economics, you give your dummy variable will be taking the value of 1. If he or she has not gone for higher education, then the value will be 0. Okay, then similarly for the same student, that is observation 1, you can collect the CGPA score, you can collect our parents income maybe in thousands. Then you can construct your model, which may look like something like this. Yeah, which may look like this, where DI you will capture the decision for going for higher education or not. That is, whether he or she is already got admitted for higher education or not. X1T can be, X1I can be the say parents income in rupees 1000, and X2I can be the CGPA score of the student, and rest of the model is same as we discussed earlier for multiple regression model. It has a slope coefficient, intercept coefficient, it has partial slope coefficient, and there is a stochastic error term UI, which you have already learned in your earlier multiple regression model. Here, as you observe, the dependent variable is taking two possible values, either going for higher education or not. So it is a binary model, okay, or it is a dichotomous model. But many times the choice is not 2, but choice can be 3. In that case, the model is a trichotomous model. Sometimes if there can be many choices, so we'll call multichotomous model or a multiple category model. Okay. So another thing is, sometimes these qualitative variables are ordered or ranked, or sometimes they cannot be ranked. See, where there is a hierarchy, choice 1 is superior, choice 2 is inferior, then there is a hierarchy. So for example, if you are thinking of the credit rating models, various credit rating agencies like S&P, Fitch, okay. In our country we have Crisil, ICRA. So these credit rating agencies, they give a credit rating to the corporates who want to borrow funds from the market. So there are credit rating like AAA, double A plus, triple B, like that. So here there is a hierarchy. Triple A is the best company whose credit rating is very high, so the default risk is almost close to 0. So triple B is relatively inferior, triple C is further inferior. So there is a hierarchy in those models. Those are ordered, but not necessarily always the models, the variables, the qualitative variables are ordered, where we cannot rank them in terms of superior or inferior. Those are not ordered. Like in this case, somebody is going for higher education or not going for higher education, or we cannot order it. Okay. uh, Now another example we can give, where we can use qualitative variables to analyze the behavior of economic behavior of the individual. That variable is, let us understand how a person decides whether to go for buying a house or not. Okay, so whether somebody is deciding to purchase an apartment, or somebody is deciding not to purchase an apartment, how somebody decides. So this decision of whether to buy or not buy an apartment is basically, we can model in terms of having somebody's annual income as well as the interest rate charged by the bank as possible explanatory variables. So if somebody is having high income, then the probability of funding the purchase of apartment is easier. Similarly, if the interest rates charged by the bank on the housing loan are low, then monthly the EMI will be low. So that may be conducive for somebody to take a decision to buy an apartment. So using these two explanatory variables, one can some sort of try to analyze how various individuals are deciding whether to buy an apartment or not buy an apartment. Okay, so these are few examples which we can use our qualitative dependent variable models to estimate the behavior of the individual. Now, in our syllabus, we have basically four types of models under this. So first one is LPM model, linear probability model. So I'll explain the details. Let me first tell you what are the models we'll be discussing. Then we'll go one after another. So the linear probability model is the simplest econometric model which we will be using for estimating a qualitative dependent variable model. This model is very simple and has many limitations which I will discuss as we take up the model. But despite many limitations, we use it as a first example to explain to the students about the linear probability model, because it is easy to understand, and this model can be estimated using OLS. Now, although this model is very simple and easy to understand, but it has many limitations. So practically nowadays nobody uses this model for estimating qualitative dependent variable models. The people use models like Tobit model, Probit model, okay, which are estimated using maximum likelihood techniques, and the assumption about the probability change in probability due to change in explanatory variables are more realistic, although it is little difficult to understand. But these are more practical ways of estimating linear dependent variable model, which is used widely. Now, after these three models, we'll be dealing with another special type of model in our analysis, which is known as Tobit model. So, Tobit model is basically used for limited dependent variable case. See, there can be, what is limited dependent variable example? There are certain situations where you have information available for all your observations in the sample for the explanatory variable, but on dependent variable you have information for some of the observations, and you don't have information for some other observations. Okay, one example is this. We are taking the example of buying a house. Now, if we modify that, how much somebody spends to buy an apartment, given his annual income and given the interest rate charged by the bank. So here, if you are collecting data from your sample, you will have some individuals who have bought apartments. So for them, you will get the value of the dependent variable. Like somebody might have purchased the apartment spending 50,000. Somebody may be 1 crore. Somebody may be 75 lakhs. Okay, and not 50,000, sir, 50 lakhs. Okay, so you have information how much these individuals spent on buying an apartment. But in your sample, there could be some people who have not bought a flat. Okay, so you will not have information on how much they are likely to spend to buy an apartment. Okay, see, think of, you are having 100 observations in your sample, and you are trying to analyze how much they are likely to spend to buy an apartment, given the information you have available on their income and the lending rate charged by the banks on the housing loan. Okay, so here your right hand side variables are clear. You have these individuals of in annual income information for all your observations, and lending rate is available, how much the bank charges. Okay, now, yeah, how much they're likely to spend for buying an apartment, that information you will not have for all. Only those people who have bought the house, for them you will have that information. Those people who have not bought the house, as of the time you are have collected this information, so you don't have information how much they are likely to spend. Okay, so the information is zero, they have spent zero, but how much they are likely to spend, that information you don't have, because you are not able to read their mind and understand how much they are likely to spend given the income and the interest rate charged by the banks for purchasing the house. Okay, so those are limited dependent variable case. That is the last model which we'll be discussing in in the set of models of qualitative dependent variable models. So let me start with the linear probability model. As I showed little earlier, this model looks very simple. It looks just like your multiple regression model. Only difference is here the dependent variable is a dummy variable. Okay, it is not your standard quantitative variable which is appearing on the left hand side. Okay, so I'm sorry, actually a0 is my intercept variable. I'll modify this. Yeah, so a0 is my intercept variable, a1 and a2 are my partial slope coefficient, x1i is income, parents income of the student, and x2i is his or her CGPA score at BA economics, ui is the stochastic error term. So di takes the value of 1 if the student has joined for MA economics, it takes the value of 0 otherwise. Okay, so this model one can apply OLS to estimate, and assume after applying OLS the model is estimated to be as given here. So it is estimated as say di is equal to minus 0.7 0.002 x1i plus 0.4 x2i. Okay, so applying OLS, you have estimated this model. Now the important thing is the interpretation of LPM model and interpretation of multiple regression model of which we had discussed earlier are quite different. In a multiple regression model, for a given value of explanatory variables, your estimated dependent variable measures what is the value of dependent variable on an average given the value of the explanatory variables. For example, if you have say estimated a consumption function, okay, where your left hand side variable is consumption expenditure and say your right hand side variable is the disposable income and maybe wealth, the second explanatory variable, then for say given income of say 2.5 lakhs and given wealth of say 10 lakhs, what is the estimated value of the consumption expenditure on the left hand side? It gives for those households who are having 2.5 lakhs of annual income and 10 lakhs of wealth. Okay, for these households on an average what is the consumption expenditure? Maybe 1.8 lakhs or maybe 3.2 lakhs, etc., etc. So your dependent variable in this case gives on an average the value of the dependent variable for given value of the explanatory variables. Okay, but in LPM model, the dependent variable estimated value of the dependent variable basically estimates the probability. So here in this model, say assume there is one student 1 whose x1i, that is parents income, is 50,000 and whose x2i, that is CGPA score, is 3.5. Now putting these values here in place of x1i, x2i for these given estimated coefficients, perhaps your d value will be estimated as 0.8. So now the d value for the student for given parents income and given CGPA score of the student, D value gives the probability of the dependent variable being 1. See, dependent variable becomes 1, that di, dummy variable, is 1 for those students who have taken admission for MA Economics. That is, those students who have opted for higher education. Okay. So, if D for a student with parents income of 50,000 and CGPA score of 3.5, for this student, if D is estimated to be 0.8, it implies that the probability that a student having this parents income and this value of CGPA going for higher education, that is getting admitted for MA Economics, is 0.8. So the estimated value of the dependent variable in this model estimates the probability. So these models, these qualitative dependent variable models, are also known as probability models. Okay. So this way the interpretation of the estimated dependent variable varies is very different compared to the standard multiple regression model which we have discussed, where your both left hand side and right hand side variables are quantitative variables. Then secondly, there is a difference in interpretation of the estimated partial slope coefficients. In our multiple regression model, which we discussed earlier, having all variables, quantitative variables, I mean left hand side, right hand side, all variables as quantitative variables, we interpreted partial slope coefficient like this. So for example, if in the consumption function model which I discussed, if the partial slope coefficient corresponding to disposable income is estimated to be say 0.6, then this implies that when the disposable income of a household or an individual increases by 1000 rupees, if the unit of measurement of disposable income is in thousands. So if the the income, household income or individual income is increased by 1000 rupees, then the consumption expenditure of this household increases by 0.6 units. Okay. So if the consumption expenditure is also estimated in thousands, so that this implies that the disposable income increases by 600 rupees on an average, keeping all other things constant. Okay. So this model, as I told earlier, multiple regression model for consumption function, has two explanatory variables like disposable income and wealth. So keeping wealth constant, so for those households, if their income is increasing by 1000 rupees, then the consumption expenditure will increase on an average by 600 rupees if the corresponding partial coefficient corresponding to income is estimated to be 0.6, right? The interpretation for linear probability model, LPM model, is very different. Here this has a interpretation in terms of probability. So like in this example, say the coefficient corresponding to CGPA score is estimated to be 0.4. So what does it mean? How to interpret? This implies that keeping all other things constant, that is keeping parents' income constant, if CGPA score increases by 1 point, okay, then the probability that the student will go for higher education, the student will get admitted into MA Economics, increases by 0.4. The probability increases by 0.4. Okay. So this way the interpretation of a linear probability model for the partial slope coefficients is different compared to the the multiple regression models with all quantitative variables both in the left hand side and right hand side. So, but these models are very useful. See, using the information on parents' income and CGPA score, you can estimate what is the probability that the student is getting admitted for MA Economics or not. For the student one with values of 50,000 as parents' income, 3.5 as a CGPA score, for this hypothetical estimated model, the D is calculated to be 0.8. Whereas for the student 2, with parents income of 60,000 and CGPA score of 2.2, the probability is estimated to be 0.3. Okay, so using these simple models, we can roughly guess whether a student is getting admitted to higher education, like for MA economics course or not. Okay, but as I said, this is a very simple model. It is easy to understand, but it has many demerits. Of course, these models used to be were very popular in 1960s and 70s to estimate qualitative dependent variable models. But for given the limitations, these models are not very popular. So what are the limitations? It has many limitations, and one very very important limitation is it is assuming linear probability, in the sense, for given change in the experimental variable, the change in probability of the dependent variable taking value of 1 is linear. I think it will be it is easy to understand if I use this graph here. So if say z is the experimental variable here, as the value of z increasing from this point up to this point, you see the probability of the dependent variable is increasing. I mean, it will be becoming 1, increasing in a linear fashion. Okay, perhaps this may not be realistic. I think of the individuals where we're thinking of they go for higher education or not. See, if when a student, those students who are having very high CGPA score, say you think of students scoring 9.1, 9.2, 9.3. So these students are very bright, right? So here the increase in CGPA score from 9.1 to 9.2 will lead to very marginal increase in the probability of getting admitted for MA score. Similarly, think of those students who are very weak and their CGPA score is very low. So think of some student is scoring 1.1, 1.2, 1.3, like that. So here again, the increase in CGPA score will lead to very marginal increase in the probability of getting admitted in the MA economics, right? So in both the extremes, at the lower value of the x variable and the higher value of the experimental variable, the change in probability of getting admitted for MA economics with increase in the value of the experimental variable will be generally low. Whereas in the middle, think of the students who are say 5.9 to 6.0. Okay, sometimes for certain admission there could be some eligibility conditions, like 60% plus above are eligible, or 55% plus above are eligible. So here the change from 5.4 to 5.5, if 55% is the eligibility for admission, is huge. That will make a huge difference in the change in probability for getting admission. Okay, you can, similar example you can think of for the buying of house problem, I mean analysis. So those individuals having very high income, say in crores. Okay, so they may have already have their own house or apartments, right? So for them the increase of income by 1000 will be not making very significant difference in the probability of buying a house. Okay, that will make only very marginal change in the probability. Similarly, those households having very low income, they may not have attained the minimum threshold amount of income which will enable them to get a bank loan for house. So for them also, any change in probability, in any change in income will lead to very marginal change or almost no change in the change in probability of buying a house or not. Okay, whereas the middle income group, for them, the change in income will lead to significant difference in relatively higher difference in the probability, or relatively higher increase in probability of buying a house or not. I think these non-linear probability will be discussing, will be when we are discussing about probit model and logit model. So at that time I'll show how the graph differs. Now these assumption of linear probability, that is the probability changing linearly or uniformly when the experimental variables are increasing is not very realistic. So this is one significant drawback of a linear probability model. Secondly, certain assumptions of classical linear regression models are violated. If you look at the values of the dependent variable here, these are 1 and 0. So it is basically a binomial distribution. Okay. So here yeah, so here the errors will not be normally distributed. Okay, the errors will be binomially distributed with the variance of p multiplied by 1 minus p, where p is basically the probability that the value of the dependent variable is 1. Okay, so the variance is p multiplied by 1 minus p, being the variance of the stochastic error term. So it is no more normal. So if you take values of p multiplied 1 minus p, this variance is not constant. So the assumption of homoscedasticity is violated. Okay, so that's a problem when in a multiple regression model, when the assumption of homoscedasticity is violated, we have certain difficulties in applying estimating these models that we have discussed. Then thirdly, the coefficient of determination r square, which used to be used as the indicator for assessing goodness of fit for our econometric models, will no more be used here. Those will no more be appropriate. Why? You can think of this. So look at the actual values of the dependent variable. Those are 0, 1, and the estimated values of the dependent variable, there will be some probability varying in between 0 to 1. So that way there will be significant difference between the actual values and the estimated values, and perhaps r square will not be appropriate to be used as a indicator of goodness of fit for these models. And there are some other indicators like pseudo r square, etc., which are used. Then again, for these models, for linear probability models, sometimes the estimated values of the dependent variable will be greater than 1 or even less than 0. So I think the value probability should lie between 0 and 1. So having a negative value for the dependent variable, or value more than 1, that violates the range of values which probability takes. So these are the demerits of linear probability model. So in the next lectures we'll be discussing about the probit model and logit model, which are more realistic and which basically improve upon the demerits of the LPM model which we discussed. But LPM model is definitely very easy to understand to start with the probability models. So we generally discuss LPM model at the beginning of